Hello guys and welcome back. So now I have a quick preview of the setup and everything is working as expected. The main thing I'm looking for is that the base water is not leaking or moving or doing anything crazy, and it's basically stabilizing. And even though we're at frame 40, you can see there's very little movement happening just here and maybe here, which is not unrealistic. Pardon me. And then we have the collision geometry coming in, and you can see there's a lot of cool intersection. Now what I'd like to do is I want to introduce some forces to this to create more turbulence and more animation inside of the, let's see if I can find the clip quickly. So right now it's very uniform, and I want to introduce these forces which are pouring in water. They're actually not pouring in, we're not injecting water inside, we're just pushing in the fluid more and more. You can see the surface is getting a lot of details. We're also going to create a force to fake in the coming, basically a boiling effect, to make it more interesting here. You can see now we're getting a lot more rippling and a lot more details on the surface. Okay, so let's see how we can do that. I'm gonna go up and let's use this section. This is fine. I'm gonna start off with from a tube geometry. And the idea is we want to place this tube facing in various ways, and we're going to create a velocity vector on it that will help to push in the fluid motion whenever this object exists. So first thing, we need to fill in this object with points, and this way we can randomize the velocity on those points. Let's use a node called points from volume. And the cool thing about this node is that it generates a uniform filling of the object, which could be more interesting to use. But I'm going to introduce a little bit of jittering as well to this volume, and I'm going to keep the particle separation to 0.1. I'm going to create a point VOP, and all I'm going to do is give this a vector and generate a noise based on position. I'm going to plug that into V, and I'm going to add a vector to this. So let's make sure this is a 3D noise, and let's expose these guys. And let's add this, and let's expose this, and let's call this direction, and it's a vector. Okay, let's go back up. Let's visualize this. You can see now we have a velocity vector. I'm going to give them a positive y, so they're pushing outward, and this is all I need for now. What I'm going to do is I'm going to copy this node and paste it in various corners. So I'm going to rotate it and paste it so that it points this way, this way, this way, and I already have the graph that I've from the previous scene, so I'm going to copy it. I will explain it in a second. Oh, so first thing, I scaled this force down like this, and then I copied it multiple times. So you can see now velocity is going to push from here, from here, from here, and here. Okay, let's call this out pump corner. And in order to be able to use this with flip, we have to convert this into a volume. We have to provide a surface field and a velocity field. That's how we can inject this force into flip. We cannot use points like this right now. We have to convert this into a volume. So I'm going to use VDB from particles. There's two nodes. There's VDB from particle fluid, VDB from particles. This one, we cannot sample extra attributes and create extra fields from them. This one, we can. So we're going to use that. Let's connect this. And let's lower the resolution of the voxel size, 0.2. And we're going to lower the point radius as well, that's used to capture the details. I'm going to lower this to 0.25. And I'm going to add an extra attribute, which is the velocity, and that's what Dobbs is looking for. And let's connect this here. I'm going to copy this path. And the trick is we're going to use particles now, because remember the flip sim is based on two things. There's a fluid, there's a smoke sim, and there is a particle sim. We can affect particles as well and control them, and that will still propagate into the sim and interact with the smoke sim that's happening internally. So let's dive back in. Let's lower the resolution to something reasonable so we can have a real-time preview or a faster preview. No, 0.02, no. That's more realistic. Okay. It's very low. Cool. And what I'm going to do is I'm going to use a pop advect by volume. And this is the same node we use to advect fields in SOPs, with particles. It's the same exact node. And we're going to connect this to the solver and use it to modify the particles. We're not going to change we're not going to change the smoke sim or affect that in any way. We're going to directly affect the particles. So I'm gonna use from SOPs. And I'm gonna untick the treat as wind, and this is going to make it basically easier to control. And I'm gonna set the velocity to 200. And something I always like to do is to add a drag, a little bit of drag to the overall scene. I'm gonna add 0.02 drag, and let's take a look. There we go. You can see it's the color is changing here, it's changing here, and here. And there is so many things we can do. For example, we can place a source underneath this one that is stronger to make the bottom part boil up, which will bring up more details to the surface. We have another one that has less magnitude that pushes at the upper level, so we can create more complexity. Let me turn this off. Cool. So you can see them appearing there. Let me increase this so we can visualize it better. And this is much stronger force. And one more thing I'd like to do right now, the velocity coming in is uniform. I'm going to go back to the source and add a little bit of animation to the velocity so it changes every frame, and this is going to create more even more randomization to the scene. Okay, let's go back up. I'm gonna lower this back to 200, and let's introduce this this noise. So here I'm going to simply add an offset. I'm going to use $FF, and reason for the $FF is when we use substeps, and let's say we have 4 substeps between frame 1 and 2, this value is going to change every substep. If we use just $F, it's going to only change when the frame changes. So we wanted to make this change and respect the substeps if we ever needed that. So the next thing is I'm going to copy this source. Okay, and I'm going to create another one that is bigger. That has more points, and then I'm going to scale it up so it's covering a wider area, and this is to fake in some boiling effect as if the statue is causing that. So basically these points, same tube, I filled it with more points, and then I added the same velocity. And let's take a look at the vector, and we have this. After rescaling it, it's this. And I'm going to let's see, what else did I do? Oh yeah, I'm going to add a little bit more breakup to this. So let's create point vol. Let's create a noise. I don't want this to be everywhere. And let's increase this. And this gives me back a negative between -1 and 1. So I'm going to clamp it. I only want the positive and negative, the black and white values. I'm going to delete some points. I don't want it to be everywhere. So $CD.x is less than 0.2. Something like that. 5. Okay, and then same thing, VDB from particle like we did here. And we can increase this a bit. I will leave it at this. It's okay. So this is the second force. It's called boiling. And let's dive back in. I'm going to copy this. I'm going to change it to out boiling. I'm going to lower this to 10. And let's hit play. You can see it's happening here. There's a color change in there. Yep, so there's a color change in the center and the force is working. So have to make sure that there's some animation on it. Yep, so we have the same animation, and this is just to vary the pattern. We can also animate this if we wanted to, so the points are not the same every frame, and this will also help add some more breakups. So I'm going to export the offset and $FF multiply by 0.2, and this way it's changing. You can also, let's lower this, you can also add on the y-axis. It's too fast. Let's divide this by 10. stuff like this. Sorry, by 2.5. Yep, something like that. Cool. So we have forces to fake the boiling added, and I think that's pretty much it for the setup. In the next video, we're going to tweak in these settings and to improve various things in the sim, and then we're going to do a high-res version. And I think that's pretty much it. Thank you guys for watching, and see you in the next video. Bye bye.